Right guys, the next thing is the types of waves, and in this particular section we're talking about two types of waves. One is called transverse and the other one is called longitudinal. I'll come to that in a minute. Now if you look at the transverse, imagine you have a rope. It's like the simulation I showed you, and you are moving the rope up and down. So the up and down movement is called vibration. And another word for it is oscillation. So these two words are the same. To vibrate, to oscillate means to shake it in a certain way, either up and down or left and right, or whichever way. The idea that vibrate and oscillate are same words. Now in this case, the first one, here's the guy oscillating or vibrating the end of the rope up and down, and the wave looks like it's gone this way. And this direction, guys, the proper way to say it, it's called the propagation. So here we go, guys, new words. Oscillation, which is similar to vibration, and it's basically the bouncing of the particle. That's called oscillation or vibration. Now the word propagation, it means here the direction of wave travel. That's what it means, the direction of wave travel. So if I go back to the definition of transverse wave, it's a wave where vibration of particles is perpendicular to the propagation of the wave. For example, surface water waves and water in a string or rope, and all the electromagnetic waves including light. So basically if I look, it's like this. The direction of oscillation of the particle is that way, and the direction of wave travel is that way. This is called again propagation. So propagation means the direction of wave travel, and the angle between two arrows is 90 degrees. If it's 90, then it's transverse. Moving on to the next one, longitudinal waves. Some people say longitudinal waves. It doesn't matter. So what it is, it's a wave in which the vibrations are parallel to the propagation of the wave. It's like when you have a slinky, guys. You know what a slinky is? Like this. And you are, you're here and you push it or shake it back and forth. So this is your vibration. And then the wave goes that way. So that's your propagation. So here, both the vibrations and the propagation are parallel, and that's what's called longitudinal wave. Here's a diagram. Here's a slinky. So you push forth and back and you get this pattern. So it looks like some of the coils they compress and some of the coils they move apart from each other, but the wave travels in that direction, and that's the propagation. So both are in parallel lines. So if the oscillation is this way and the direction of propagation is this way, and so you get yourself a longitudinal wave. And that is this section of the lesson.